Hi, I'm Piper Merriam, and today I'm going to talk to you about scaling, kind of specifically in the context of Ethereum. You can find me on the internet. I work for the Ethereum Foundation, team lead for the Python team. We build a lot of developer tools. Cool. So let's talk about where we are today, because the concept of scaling, you kind of need some baselines, and this is sort of my picture of the world. Bitcoin, we've got 7 transactions per second, Ethereum, 20 transactions per second, and then we start getting into these other things and we get much bigger numbers. Visa and MasterCard, I found a wide variance, but essentially if we want Ethereum to be this majorly adopted mainstream thing, we've got a long ways to go. We're off by 2 orders of magnitude here. Another way to look at these numbers is like this. PayPal's 100 times slower than MasterCard, maybe. Ethereum's 2,500 times slower. So you get the idea here that we're really a long ways off in terms of scaling. So this is where we are today, and this is where we're trying to go, depending on if you like DeWalt or not. So the general idea here is that right now people are building production applications on what is effectively a toy. The Ethereum blockchain isn't a toy, but it's still super slow and clearly can't handle real application capacity. So scaling is one of the holy grails, in my opinion, of blockchains. And so we're going to talk about kind of 2 different approaches. Layer 1, Layer 2. So Layer 1 is core protocol, things that are part of the core Ethereum protocol that make it faster. And Layer 2 are options that we layer on top of the core protocol that allow things to be faster. And we'll talk about some specific instances of these. So Layer 1, things that I'm going to talk about today are EWASM, proof of stake, and sharding. I'll talk a little bit more specifically about each of those when I get to them. But all of these require hard forks and are kind of core Ethereum protocol things. Layer 2, I'm going to talk about TrueBit, Raiden, and Plasma. And these do not require forks. They're built on top of the core protocol. Cool. So let's talk about Layer 2 things first. Okay, so TrueBit is a scaling solution that allows you to move computation off of the chain. So something that's way too expensive to actually compute on the blockchain, we essentially delegate it to somebody outside the blockchain, let them do the computation, submit the result, and I'm not going to explain exactly how all of these work. It's worth digging in, but the general idea is that there are things that we probably will never be actually computing on the blockchain. But that doesn't mean that we can't give applications on the blockchain access to them. Things like the technology that applications use to store your passwords are intentionally very slow algorithms that require lots of memory and lots of computation. And running those on the blockchain is prohibitively expensive. So that's why we have, this is a potential solution for those types of things. It allows you to move these things off-chain. This is an application-specific speed up. It isn't going to be kind of a generic across-the-board thing that speeds everybody's applications up, but there are plenty of applications that will be able to make use of this. Another one is Raiden. So Raiden is a system for payment channels, essentially meaning that 2 parties who want to pay each other can, and maybe want to exchange a bunch of payments. You can think of a bar tab. You might open up one of these payment channels to pay your bar tab, right? As you order more drinks through the night, you issue more payments for them rather than paying for them one by one. And the idea is that you can make a lot of payments at the cost of basically 1 or maybe 2 actual transactions on the network. There are some trade-offs that we get with all of these. One of them is just sort of the overhead of you've got to put a deposit down for that bar tab ahead of time to make sure that you have enough money to pay for it. There's some overhead for handling disputes and settlement, things like that. But in general, this solution right here can provide MasterCard and Visa level transaction throughput for payments. So that is for payment specific. So payment channels are likely going to be a big piece of scaling because a lot of the use cases for blockchains are payments. And Plasma. So Plasma, I'm going to admit that I don't have my head entirely wrapped around how Plasma works. But nonetheless, Plasma is a major scaling solution for Ethereum. It's effectively lots of different side chains that are all secured by the main chain. And the idea is that you can create application-specific ones. So you might be able to move the entire CryptoKitties application off of the main chain into this Plasma side chain. The throughput can go way up. And there's, again, trade-offs to these things. But Plasma is intended to provide a pretty significant scaling solution for certain types of applications. Again, this is application-specific. All of these are not things that everybody's going to be able to take care of, but many applications will be able to get some like serious speed increase from these. The layer 1 ones are the ones that are most interesting to me. So let's talk about EWASM. EWASM is based on WebAssembly, and WebAssembly is a standard that's been worked on for essentially finally getting us to a point where JavaScript isn't the only language that we can use on the web. And the idea is that there's a bunch of smart people who've been working on implementing the Ethereum virtual machine under this engine. And the idea is that there are a lot more resources working on WebAssembly than there are people who are working on the Ethereum virtual machine. And so if we can kind of switch over to building on top of their technology, we're going to get a lot of benefits for free. Some of the cool things, it lets you compile from like normal languages into stuff that can be run on the Ethereum blockchain. So really important stuff like cryptographic primitives that have existing implementations in C or things like that, we can actually leverage those to be used as part of the EVM. But in general, it's going to be more performant, things like that. And it's hard to get numbers on these because all this stuff is in research, is in a research phase right now. But we could see some pretty serious like speed improvements, and this is stuff that applies to every application on the blockchain. So 100 to 200 time speed improvement is a pretty significant improvement to how fast things can execute. The next one's proof of stake. So proof of stake is not specifically intended to be a scaling solution. It just happens to have some properties to it that will allow things to speed up a bit. Without getting too much into the nitty-gritty of it, by switching off of proof of work, the people who are mining blocks now can spend more of the time that they're spending mining the block actually constructing the block rather than spending all that time hashing. So we're going to get some like maybe 2 to 10 times speed improvements here. And then sharding. So sharding, the general idea is that you split the chain up into lots of different individual chains that can all be run in parallel. Right now we have this one chain and it runs sequentially, and you can only do it as fast as you can run it in like a single thread, basically. And the idea is that with scaling, we can split it up into, I think the initial approach is going to be 100 different ones, so effectively we get like 100 times speed increase. And while this is still being heavily researched, there is promise of what I think the research team is calling super quadratic sharding, which could give us thousands of times of speed increase. It's essentially just massive parallelization of execution. So in summary, we've got TrueBit, which is this sort of, we've got these three, I'm really low on time, so I'm going to blast through these. We have the kind of like these three application-specific things, TrueBit, Raiden, Plasma, and there's plenty of others. This is just the ones that I chose. And then we get these layer 1 ones, Casper, EWASM, and there's plenty of others. This is just the ones that I chose. And again, the numbers that I put up here on like what the actual performance gain is are and then we super fuzzy. Layer 1 really ones, Casper. But if you multiply all of those up together, we get somewhere close to those. And Ethereum again, the numbers that I put up here on like what the actual card Visa transaction throughput. Layer 1 ones, Casper,
But if you multiply all of those up
and there's
together,
plenty of
we get
others
somewhere
sharding
close to
ones.
those. And
Ethereum
again, the
hits
numbers that I
that
put up
point
here
where
on
it's
like what
hitting
the actual
MasterCard,
Visa
the question is
transaction
which
is.
layer 1 solution is closest. The answer to that is Casper. So Casper. Casper hard fork, and we won't actually get any of the speed increases there because it's a hybrid between proof of stake and proof of work. But once we are fully on Casper as the security mechanism, then yes. Sharding isn't going to be too far behind that.
What's the consensus and policies on like running private Ethereum blockchains, and how does that relate to the main chain with transaction and stuff?
The question is, what's the policy on running private chains? You can do it if you want to. A lot of companies are running private chains to connect their backends, or at least experimenting with it. But they can effectively leverage whatever technology is being built for the public chains, because most of that stuff is compatible with a private chain. I think you.
When do you see this catching up to MasterCard and surpassing it in 20 years?
The question is, when do I see this catching up to MasterCard? I'm notoriously bad at predicting the future. So if I were to ballpark it, I'd say within the next 10 and probably 5. Things happen faster and faster as they happen. So we're still in kind of like the flat part of the curve, in theory. And as things start to speed up, I think that it'll pile on and happen faster.
Are there any plans to include human readable keys or account recovery directly into the core of Ethereum rather than having each application have to work with a third party?
The question is, are there any plans to include human readable keys or account recovery into the core Ethereum protocol? Right now, I know of no proposals that are really being considered for that. My personal opinion, so this is nobody else's, but my personal opinion is that those are things that don't belong in the core protocol, and that the core protocol is not intended to be user-friendly. It is not something that needs to be friendly to the end user, and that's all stuff that can be handled in kind of layer 2 solutions.
Do you think that the MasterCard numbers are a good analogy? Because we're really talking about function calls here, not just payments.
Yeah, so his question is, are the MasterCard numbers a good measure? And I really should have prefixed this with transaction per second are actually not a very good measure at all. It's just a measure that we can look at. Since the Ethereum protocol is not a ledger, it's a virtual machine, then we're really talking about like computations per second. But now it gets really hard to compare that to something like real-world production grade. Like, do we talk about Amazon Web Services and how AWS compares to the total compute power there? So it's a really fuzzy metric, but transactions per second are an easy, accessible metric.
What's the roadmap for like WebAssembly? Using the WebAssembly virtual machine, and does that affect interoperability at all?
The question is, what is the roadmap for EWASM, and
Does it affect like interoperability?
And does it, okay, so the first part is there's a chance that EWASM starts to show up in either the next hard fork or the one after that. The EWASM research team has something that's pretty much ready, and to the best of my understanding. And I don't understand your interoperability question.
Well, because I think there are like other blockchains that are working with WebAssembly as well. So I was just wondering if that could like help.
I don't think, even if another blockchain is building their VM on top of WebAssembly, unless they're building on the EVM, then they're going to be fundamentally different machines.
So there's multiple Ethereum clients that are developed by different parties that aren't all necessarily connected. And the one, the Ethereum Foundation, doesn't have as much functionality as like the parity one, for instance. Do you see like a different process by which you can get more features on?
I'm going to challenge that. So the question, the question, which includes an assertion in it, is that the client developed primarily by the Ethereum Foundation, which I believe you're talking about Go Ethereum, does not contain as much functionality as the parity client. This is a really complicated topic for me because the parity client is implemented in ways that there's shortcuts in there that they've taken, and if the Go Ethereum client wasn't on the network, then the network would not be nearly as healthy as it was if the entire population of it, and whether or not that's the case today, I don't exactly know. But I know that there are very clear points in history where the parity client is considered superior and faster and better, and the reason that it's faster and better is because it's not being a good citizen on the network. So you can do that when you're a minority client on the network, but as the majority client, Go Ethereum is generally implementing things in a safe way that's intended for like a really healthy network, which makes the individual client potentially slower. So, oh, that's it. We're out of time.
All right, thank you. Right here.
Thanks to all of our speakers. I'm going to take a picture of you all. Sorry, that I'm required to do. Thank you. Yeah, if you want to join us on the patio for more conversations, please do. Thanks for coming out. Oh, Colorado coin. If you want Colorado coin, see Dan, see John, and have fun.